All right, we are continuing our study of the gas laws. Today is our third gas law that we have learned. So let's take a look at who this one is. This one is Gay-Lussac's law. So just like the previous ones, the researcher who was able to eloquently state the law and provide backup data is who it was named after. So Gay-Lussac's law states that the pressure and absolute temperature of a gas are directly related. So, as one increases, so does the other. So, as pressure increases, temperature increases. As pressure decreases, temperature decreases. Okay? And this is only if the mass and the volume remains the same. Okay, can't change too many variables or it changes the pattern. Okay, so if mass and volume are staying the same, then pressure and temperature will change together. Pressure will increase as temperature increases. Now, remember, with gas laws, as always, our temperature needs to be in Kelvin. Okay, if you use the degrees Celsius in the equation, you are not going to get the correct answer. Okay, we have to use Kelvin. So go ahead and write this equation on your equation sheet. Get that added in and do your key with it as well. So the P's here, just as it was previously, P is for pressure. The types of units we will have with pressure are either atmospheres or kilopascals are also okay. Temperature has to be in Kelvin, okay? So problems may give you degrees Celsius, it may give you degrees Fahrenheit, but you've got to convert those into Kelvin first. And when you answer, depending on the way the question is worded, you can provide Kelvin, or it may specifically ask you to provide your answer in degrees Celsius. So if that's the case, be sure to pay attention so you don't get tripped up, okay? All right, so let's look at an example problem and work through it. Okay, so a gas's pressure is 1.3 atmospheres at 23 degrees Celsius. At what temperature will the pressure be? 0.5 atmospheres. So let's work through the problem. Let's start by looking at what do I know. So I have a pressure of 1.3 atmospheres. I have a temperature of 23 degrees Celsius, but I cannot use Celsius. So let's go ahead and convert that into Kelvin by adding 273. So that's going to give me 296 K for that temperature. At what temperature, so that's my unknown, will the pressure be 0.5 atmospheres? Okay, so there's the information provided in the question, pulled out for me so it's easy to see and plug in. So I'm going to look at my equation sheet and say, okay, what equation do I have that has two P's and two T's in it? And I'm going to see that it is my Gay-Lussac law. And here's my equation. So let's go ahead and just plug those numbers into the equation. When I do that, it's going to look like this. Now remember, we've got to be careful, making sure we don't mix up which part of the problem, which side of that equal sign my P's and T's go. We've got to make sure that we keep the ones together, those initials together. So 1.3 and 23 go together here. Okay? All right, so 1.3 divided by 296 equals 0.5 over x. Okay, filled in with my x. So the first step of this problem is on the left-hand side, 1.3 divided by 296. We can go ahead and do that math. So let's do that. Pop that in my calculator, and I'm going to get 0.00439 and a whole bunch more numbers. Okay, since I have asked you guys to give me two decimal places, you want to keep three numbers until the very end, okay? Or your number is going to keep changing as you go through. Okay, so go ahead and keep those three. So 0.00439. Now, none of those units canceled off, so I have to keep those units. So it's ATM over K. Got to keep those units because nothing canceled. Okay, this side stayed the same. I didn't do anything to it, so it's still 0.5 over x. Okay, now we're at the point of the problem where it's time to try to get that x by itself. Well, the x is on the bottom. So the first thing I got to do is get it off of the bottom. So we're going to need to multiply both sides by x. Okay, so we're going to multiply both sides by x. What that does on this side is it puts an x on the top and an x on the bottom. So those are going to cancel each other out, and x is off the bottom. Now x is over here with this. Okay, so that turns my equation into 0.00439 times x equals 0.5 atmospheres. Okay, now that we've got x off the bottom, let's work on getting it by itself. So since this is multiplying, we have to divide both sides by this number. Okay, and that's going to put x all alone and give me the answer to the problem, because I can do some canceling at this point. Okay, on this side, these are identical, one on top, one on bottom, so they cancel off, including that unit. And on this side over here, both of those units get to cancel off. Okay, we are left with K for Kelvin, and that's good because my answer is a temperature, so that's awesome. Okay, and now I'm just going to do this math. 0.5 divided by 0.00439, and I'm going to get my answer. 113.90 Kelvin. So when you put this in your calculator, you're going to have 0.89 and a bunch of numbers. Okay, I rounded to 2 decimal places. So following those rounding rules, I got 113.90. Now, this problem did not tell me what temperature it wanted the answer in, so I could provide the answer in Kelvin, or I can turn that into degrees Celsius simply by subtracting 273 from my Kelvin answer, and then I can provide the answer in Celsius. Okay, so either one of these would be correct with the wording of this problem. Once again, if you don't know how to do this, if you are lost and confused and you need help getting this answer on your own, get into contact with me and let me help you out so that you can do this on your own, because that's what's up next. Next is Gay-Lussac's gas law independent practice.